Okay, here we have a problem, and a coin is tossed 4 times. How many ways are there to get 3 heads? So what I would think to do is draw a probability tree of 4 coins being tossed. So got heads or tails. And that's my first coin. So that's my first toss. You either get heads or tails. Then my second toss, you either get heads or tails. Same over here. My second toss will be a heads or tails. And then my third toss will be a heads or tails. Heads or tails. Then I'm going to do the same over here. You either get a heads or you get a tails. You either get a heads or you get a tails. And now my fourth toss, my final toss, you either get a heads or a tails. Heads, tails. This is just getting out of hand. It's really messy. Heads, tails, heads, tails, and then final over here. Heads, tails, heads, tails, heads, tails, heads, tails. I've already forgotten what the question is by now. We've done this so many times. And now it says, how many ways are there of getting 3 heads? So if I think I've got heads, then I get a heads, then I get a heads, then I get a tails. Here's one way. What else is there? You get a heads, a tails, and a heads. Here's another way. Got a heads, tails, heads. Got another way. Is there anywhere else? Anything else? We've got tails, heads. And I'm trying to see, do we have any other ways where we can get 3 heads? Tails, heads, tails, heads. No, I think that's all. We've got all the options where you can get 3 heads. Right, now looking at this mess, you can see there is like all these branches. Surely there is an easier method to find out the number of ways to get 3 heads when you have 4 coins tossed, or a coin tossed 4 times. And there is. So let's have a look. Now on your calculator, you have this function, n choose r. It's also written as this sometimes when you're doing your workings out on paper. Now what this is, say if I say n equals number of coin flips, and then we can say r equals number of heads, and you do 4 choose 3. If you type that into your calculator, which you type it in as 4 choose 3 like that, this will tell you all the possible ways you can get 3 heads with 4 tosses of a coin. It does all the combinations for you. It uses this formula over here. So I have 4 with an exclamation mark over 3 with an exclamation mark, and then 4 minus 3, which is 1, with an exclamation mark. And then I'll explain what these exclamation marks mean in a second. To find the C button, or the choose function, you have to press shift in your calculator, or my calculator anyway, and then you press the divide button. Shift, then divide, it should come up with the C. And then you write 4 C 3, or 4 choose 3. And that tells you all the possible ways where you have 4 tosses of a coin, and the number of ways where you can get 3 heads. There are 4 ways. Okay, now let's explain what the actual calculation is. So you have 4 with an exclamation mark. When you have an exclamation mark, all it means is you're timesing downwards from 4 down to 1. So if you have this notation is called a factorial. So this is called 4 factorial. And what it means is you're timesing all the way down until you get to 1. If I had 5 factorial, you'd have 5 times 4 times 3 times 2 times 1. That's all it means. Factorial means you times all the way down until you get to 1. So this would be 4 times 3 times 2 times 1. And on the bottom you have 3 factorial, which is 3 times 2 times 1. And then you have 1 factorial, which is just times 1. And now you can cross out everything. The 3's cancel out, the 2's cancel out, the 1's all cancel out, so you're just left with 4, which is the amount of ways. Luckily, you don't have to use this formula because the calculator just does it for you. Just write 4, the choose button, and then 3, and it has told you 4 ways. That is all the theory behind the N choose R button on your calculator. This leads on nicely to the introduction to the binomial distribution. When you are carrying out a number of trials in an experiment or survey, you can define a random variable x to represent the number of successful trials. We'll look at the coin example in a second to see what I mean by this. For a binomial distribution to be used or used as a model, it needs to be these 4 conditions have to be met. There has to be a fixed number of trials. So for example, when we were throwing the coin, we were throwing the coin 4 times. So the number of trials which is labeled as n would be 4. There are 4 trials because you're throwing the coin 4 times. 2 possible outcomes, success and failure. So in that case, success would have been if the coin landed on the heads, and failure would be if the coin landed on tails. Fixed probability of success. Obviously, if you're tossing a coin, the probability of success is going to be a half each time. It has to say the same. If the probability isn't constant, you can't use a binomial distribution as a model. And trials are independent of each other, which means throwing the coin once and getting a heads won't affect the probability of getting a heads the next time you throw the coin. The trials are independent of each other. If the conditions are met, you can express the distribution as x equals the number of something. You'll know depending on the context. Then you write x as this: x, squiggly line, b, n, comma, p. This reads as x is binomially distributed with n trials and probability of success p. Now, as it states here, n is the number of trials and p is the probability of success. These 4 conditions have to be memorized. You need to know them off by heart. How I memorize them is remembering this F, F, I, T. You need to, so if you remember this, which is just fit with an extra F, you can remember fixed number of trials, fixed probability of success, trials are independent, that's not how you spell independent, independent, and T is for 2 possible outcomes, which are success and failure. So now let's see how closely it matches. So fixed number of trials is that one. Fixed probability of success is that one. Trials are independent is that one. And 2 possible outcomes is that one. So FFIT works perfectly every time. So if that's how you want to memorize it, that's how you can memorize it. If you prefer to just memorize it in a list, you may want to put it on a flashcard or something, then go you. I guess you can do that. So here is the formula we're going to use to calculate probabilities when we're using a binomial distribution. You have the probability that x equals x is n choose x, which you can either write as that or n choose x or n choose r. In this case, we've just used it at x, but it doesn't make a difference. Times the probability of success to the power of x. And then 1 minus p is the probability of failure to the power of n minus x. And you'll memorize this through practice, hopefully, because this is not in the formula book or formula sheet from what I remember. So, a coin is tossed 4 times. How many ways are there to get 3 heads? First of all, now we're going to start defining stuff as if we were to do a binomial distribution question. We would say x equals number of heads. So this shows what we're recording. When you throw a coin, we want to find out the number of heads. And we can say x is binomially distributed. How many trials are there? There's 4 trials. And the probability of success is if you land on a head. What is the probability of landing on a head? Half. So here is our binomial distribution. Writing it in this form makes it easier to do calculations because you know what most of your details are. You know what n is, you know what p is, you know what 1 minus p is, and you know what that is. The only thing you need to know is what x is. It says how many ways are there to get 3 ways, to get 3 heads. I'm going to change this question. What is the probability of getting 3 heads? So that would be written as the probability of x equaling 3. So now let's use this formula. N choose x, 4 choose 3, times the probability of success, which is a half, to the power of x, which is 3, times 1 minus p, which is also a half, to the power of n take away x. So 4 take away 3, which is 1. You then type all of this into your calculator. 4 choose 3 times 0.5 cubed times 0.5 to the power of 1. And you get the answer 1/4. As you can see, this has gone to quite a nice answer. This doesn't always happen, but in this case, it is quite a nice answer. That is the first way we can use our binomial distribution. I know it seems like a lot, but it does get easier with practice. I just want to know, when I do this formula, I remember 1 minus p as q, because q is the same for when you get to higher maths or higher statistics, q is the same as 1 minus p. So if I write this formula, I'd write it as the probability of x equaling x equals n choose x, p to the power of x, q to the power of n minus x. Whatever sticks in your head. I prefer this notation, but you may prefer that notation. Your choice. Okay, here we have the discrete random variable x is binomially distributed with 12 trials and 0.16 as our probability of success. We're trying to find the probability that x equals 0. So first thing you need to do is memorize your formula, which is probability of x equaling x equals n choose x times the probability lowercase p to the power of x times q, which is 1 minus p, to the power of n minus x. So here we have 12 choose 0 times the probability, which is 0.16, to the power of x, which is 0, and then times q, which is 1 minus 0.16, so 0.84, to the power of n minus x, so 12 take away 0. Now you just type that into your calculator. 12 choose 0 times 0.16 to the power of 0 times 0.84 to the power of 12. And I'm going to give my answer to 4 decimal places. 1, 2, 3, 4 to 4 decimal places. If you get an ugly answer, it will tend to tell you how it wants it rounded. If it doesn't tell you, I normally round to 4 decimal places for probability. Now let's look at part B, the probability that x equals 2. Remembering that this is n and this is our probability of success. So the probability that x equals 2 is 12, because there's 12 trials, choose 2, times the probability of success, 0.16 to the power of x, times 1 minus 0.16, or q, to the power of n take away x. So 12 take away 2 is 10. Now you go to your calculator and you type all of this in. So 12, choose 2, times 0.16 to the power of 2, times 0.84 to the power of 10. And I get 0.2955 to 4 decimal places. Have a go at this question over here, and I'll go through it in a minute. So with this question, first thing I noticed is I don't have any defined variables. So I'm going to define x as x equals number of times spinner lands on 5. And let's look. How many numbers do we have? We have 1, 2, 3, 4, 5. We have 5. X is binomially distributed. How many trials? He's spinning it 7 times, so that is how many trials we have. And the probability of it landing on 5 is 1/5. So find the probability that he lands on 2 5s, or they land on 2 5s. It doesn't say if it's a boy or girl. So probability that x equals 2 is n choose x times the probability of x, the probability to the power of x times q, which is 1 minus p, to the power of n take away x. So 7 take away 2 is 5. Now you go to your calculator and you type all of this in. 7 choose 2 times 1/5 to the power of 2 times 4/5 to the power of 5, and you get 0.2753 to 4 decimal places. And then the probability of the spinner landing on 5 3 times, the probability of x equaling 3, and you get 7 choose 3 times 1/5 to the power of 3 times 4/5 to the power of 7 minus 3. 7 minus 3 is 4. Type this into your calculator. 7 choose 3 times 1/5 to the power of 3 times 4/5 to the power of 7 take away 3, and you get 0.1147 to 4 decimal places. And yeah. Okay, so now here are some questions for you to have a think about. I'm not going to answer all of them. I'm only interested in answering these ones. So if you want to have a go, off you go now. So we've been given x is binomially distributed with 10 trials and the probability of success is 0.7. Remembering the formula, the probability that x equals x is n choose x times the probability lowercase p to the power of x, probability of success, multiplied by the probability of failure to the power of n take away x. So now if we're looking at the probability that x is greater than 1, well, that's going to be the probability of x equaling 2 plus the probability of x equaling 3 plus the probability of x equaling 4 plus dot 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 all the way up to the probability that x equals 10, because there are 10 possible, there are 10 trials. So you're getting probability of 2, 3, 4, 5. We're not going to go all the way up to 10. That's going to take way too much time. What's a quicker way of doing this? X is greater than 1. What aren't we interested in? We're not interested in the probability of x equaling 1, and we're not interested in the probability that x equals 0. So a quicker way, you can just do 1 minus these probabilities and then take whatever's left. I think that would be a quicker method. I'm not going to answer this. If you want me to give you the answer, it will be in the comments if you want me to. And probability of x equaling 3, what you'd have to do is the probability of x equaling 0 plus the probability of x equaling 1 plus the probability of x equaling 2, and that would tell you the probability of x being less than 3. Give these questions a go, let me know what you get, and I will let you know if you've got them right.